Good day everyone. In this video, we will be talking about permutations with restrictions, specifically on items that must not be together. So our first problem is, in how many ways can 5 men and 3 women be arranged in a row if no 2 women are standing next to one another? The first thing we can do to solve this problem is to visualize it. So we can make a total of 11 underscores, which will represent the possible arrangement of where these people can situate themselves at. Given in the problem, the women should not stand next to one another. Hence, we chose these spots for the men. Now that we can visualize the problem, we can start to solve it. We will write 5 factorial, which represents the 5 possible spots where these men can rearrange themselves at. Then we'll multiply this factorial by 6, since this represents the 6 empty slots where the first woman can situate herself at. Then we multiply this by 5 for the second woman. Lastly, we will multiply this by 4. After multiplying this equation, we can get a total of 14,400 possible arrangements. So our next problem is, in how many ways can the letters in the word success be arranged if no 2 S's are next to one another? First thing we can do is to separate U, C, C, and E from the S's. We can put a subscript to C's, to the C's, and to the S so that we can differentiate them from one another. Just like the previous problem, we can do the underscore trick to visualize or help us understand this problem better. Since it is given that there are no 2 S's that must be next to one another, then we can assume that the U, C, C, and E are placed in these spots. Now that we know that, now that we have a visualization of the problem, we can begin to solve it. So since there are 4 possible spots where U, C, C, and E can rearrange themselves at, we will put 4 factorial. We will then multiply this by 5, since there are 5 spots where the first S can situate themselves at. We'll multiply this by 4 for the second S, and then 3 for the third S. After this, we will divide 4 factorial by 2 factorial since there are 2 C's. This is done to avoid replications. Same is done for the 3 S's. We will divide 5 times 4 times 3 by 3 factorial. In the end, we will get 120 possible arrangements.